all, welcome to another video of Corpnce. I'm Rono Savio, and in this video we'll be discussing on advanced data types. So let's dive in. You have this list, right? I'm taking an example of a list, and in list I'll show here in my screen. You can see that I'm assigning a list. I'm saying A equals with 1, 2, 3, 4, 5. Okay. Now your list is working pretty fine to access values. It do some operations also. It's very good and stuff. But let's say you want to pop those values. Let's say you're popping a of 0. Okay, a of 0. So in order to pop this, so a of 0 is 1, index position starts from 0. So I'm saying a dot pop nothing but removing the value of 0 index position. You pop the value. Now if I say a of 0, you can see the first index position is 2 now. Notice that when you popped from the left hand side of the particular list where the first value has been popped, all the values from the right shifted one step ahead. That is nothing but order of n. So order of n is slower. I told you, when it is order of n, when it comes to time complexity, you have to iterate through each and every values, like it is linearly proportional to the time complexity. So now how do we tackle this? How do we make it more memory efficient? That's where DQ comes into play. So here let's import this DQ. So let's say from collections import DQ. Okay, so we have a DQ and let's use this DQ for our list. We want to make our list more efficient and faster one, right? So normally we'll say A is our DQ object and DQ, and we'll give the particular list of values. Fine. Now in DQ, I told you that when you're removing that value from the first end, like say a of 0, you remove that value. You can see the example here. When you do a dot pop, your whole elements are shifting towards left side, and that is causing order of n, and it's making your list much slower. What if you had a million values? You have to shift all those million values one bit ahead. Now you have a DQ which will make it more efficient with order of 1, and also it keeps a dot append is fine. Append, right? So if I print a, let's see what is inside this. So this is a DQ object. If I say a dot, there is something called as append. Append already is there in list, nothing new. Append to the rightmost value, it just keeps on. There is also something called as append left. So if at all you want to append a particular value, it takes a argument as integer x. So I can say 23, and if I print a, you can see I have appended the value towards the leftmost side also. So append is there, append left, and what else is there? So let's see, a dot extend left. So same way how you did append, you can also do extend. So extend takes iterables. So I'm passing one more list, and this will literally extend it. Oh, this was append left, sorry, extend. Yeah. So append took it as a single argument, extend will remove it, and you know exactly how extend works. So yeah, this is what happens when you're using DQ. You get a lot more flexibility. Above that, you're getting it in the order of 1. You're not changing anything. You're not going in the order of n for time complexity. You're going it in the order of 1. So that makes it more powerful, because even though you have a million values in your particular DQ, you don't have to slow it down. You are never going to slow it down. That's one of the best things that you can do with DQ. So here I have a code written for you guys. So you can see how this DQ is much faster than your traditional list. So I'm gonna run this code. I'm gonna go here and I'm gonna run this, and you can see it is taking my time. It's going for a few seconds. It's gonna run, and you see the time taken for list is 6.3 seconds. 6.3. You can ignore those point values further. DQ time is much faster. You can see it is 0.009. That's lesser than microseconds. Too fast to be having DQ to be used. So this is a huge gap. Like, you have a very huge difference when it comes to list and DQ when you're using it. So yeah, this is what I wanted to show you. So in simple, DQ acts like a list, but it's very efficient and faster to have much more insertions and removals if at all you have it. So here there's one more problem that we are facing. So let's say you have this tuple, your traditional container of Python, one of the traditional containers, tuple. And in tuple, you try to store the information like the coordinates or the data of some person, because they provide that security, because once you store the values, it is fixed. You cannot change the values, you can only access the values, which is very good for security wise. But the thing is, the readability is less. So here, if you see my screen, you can notice that I have this what you say tuple with some data. I'm saying Ananya is name, age is 27, she's a developer, she's in Bangalore. But when I say print a of 0, it's Ananya. I can somehow guess it, it's a name. I don't have a label to it. Now if I say print employee of 1, I'm getting her age, but it can be something related to her what do you say, resume or something else. It can also be her hobby, or maybe a number, a lucky number. Who knows? We can be confused. That's my point. We can be confused. We don't know exactly what these data are. We don't have that readability. So what we do, we have advanced data type called as name tuple that help us tackle this problem. Let me show you how to use this name tuple. So here I'm going to import from collections, right? So in order to import, say here from collections, import, spelling is wrong, yeah, import name tuple, named tuple. Okay, now you have this name tuple, you have to create a variable, you have to make it an object, student. So I'm just naming the variable as student, and I'm saying named. I'm calling my advanced data type name tuple, and I'm passing in 2 arguments. First one will be the name for it, the label that you're giving those values. Okay, so I'm saying I want to keep label as students, and those students have 3 features. One will be their name, age, and their marks. Okay, fine, marks. Okay, so name, then next one will be their age, and next one will be their marks. Okay, and this is the second argument, second parameter that you're passing in. The first one that you're passing is the name, so the label that you are giving this. Fine, everything is set. Then what you're gonna do is student. You have to say S1. So the first student that I'm going to assign it to my name tuple is student of STUD, bro. Okay, STUD. Okay. Now I'm saying the first name will be, I'll just give my name itself. Oh no, and he's 22, and he let's say I passed. Let's keep it 50. Okay, fine. Then I'm saying student 2. Let's keep a random student. Not getting any names. Okay, let's go with one. ESP 23. Let's go with 75. Okay, I'm getting the spelling wrong. STUD. Okay, now notice that this is very readable. If at all you had a traditional tuple and you pass in these values like this, just randomly, like respectively, if you give it also, it won't make much sense. You don't know where, what, when. So now in this one, this name tuple exactly has this features of this dictionary and also a tuple. Dictionary, because if you notice here, you have a student and the name label, it's like a key, and the values, name, age, marks, those are your values. So that is a feature from dictionary, you can see that. And this name tuple is immutable, because the values you are assigning, once it is assigned, you cannot change it. So I'll show you how. So if at all I want to access these values what I've assigned, so I can say S1. So S1 is nothing but student 1. Damn, okay, it's there. So if I say S2, it's also there. Now if I try to access like this, get item. Okay, get item is a random method that is helping you to access your name tuple has it. The proof is this one. But anyways, this is exactly how even your traditional tuple also does. So in traditional tuple, if you try to change the value, it throws an error. And I told you this one named tuple also has a feature of this traditional tuple. So if I say a of 0, I mean s1 of 0 into 1000, okay, I'm changing my name to 1000 and it doesn't work. See, that's what I meant. So now if I try s1 of, now you're accessing value with index positions. That still is like, some people are like, no, I want that readability. I want to say s1 name of that particular student, the first student, s1 his name. So I'm saying s1 dot name, much more simple. So make sure it's not whatever you have given here. So n is capital. It depends on you, can give it small letter also. Yeah, that's my name there, student 1. And if at all I want the student 2, just change this one. Yeah, you get it. So this makes it more clear, more readable, and this one is more fast too compared to tuples. I mean, tuple traditionally is faster and more efficient. This one is more faster to adding these values into it. It goes in order of 1. So this applications of this name tuple, they are used for RGB colors. If at all you want to categorize those colors accordingly based on your requirements, you use this name tuple. If at all you have records like configured records where you want it to be constant throughout, you can use name tuples. The reason is it is immutable, it provides safety, security and guarantee, you can say that. But yeah, name tuple is very fast and efficient too. That also stands out. That's the reason why you can use name tuples in most of the cases when at all you want to organize or group data accordingly. So that's all for this video. I hope you found this helpful. If it did, do subscribe and stay tuned for the next one. Thank you.